Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. Manish Chaturvedi sir, seminar coordinator D.P. Sharma sir, faculty members, examiners and my fellow batchmates. I am Krishnam Sharma, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota. The topic I have chosen for the seminar is continuously variable transmission. This is going to be our list of contents. Firstly, the question arises that why do we need to use continuously variable transmission or CVT? One reason that can be given is the fact that the traffic condition has become annoying in our big cities and fuel conservation is very high. In such a case, it doesn't make sense to use automatic transmission for an Indian consumer. This is where CVT or continuously variable transmission comes into play. Before going further, let us take a brief look at the basics of transmission. The job of the transmission is to change speed ratio between the engine and the wheels of an automobile. The transmission uses arrangement of gears to make more effective use of the engine torque as driving conditions change. The continuously variable transmission or CVT replaces this discrete gear ratio system with infinitely adjustable gearing through one of several basic CVT designs available. Thus, we can summarize a continuously variable transmission as a transmission that can change seamlessly through an infinite number of gear ratios between maximum and minimum values. Now we'll take a look at the basic overview of CVT. CVT can be categorized by the following points. It varies the transmission ratio continuously, shifts automatically with an infinite number of ratios, seamless power delivery, constantly changes gear ratios as per the need to optimize the engine efficiency. Now we will take a look at some of the components which are used in CVT. These are a variable input driving pulley, an output file, a metal belt/rollers, and sensors and microprocessors. Now we take a look at the working principle of the CVT. In CVT, there exists a pair of variable diameter pulleys, each shaped like a pair of opposing cones with a metal belt or chain running between them. One pulley is connected to engine, the other to the drive wheels. As the pulley's halves come close together, the belt is forced to rise higher on the pulley, effectively making the pulley's diameter larger. Changing the diameter of the pulleys varies the transmission's ratio. This is how a CVT works. Now let us look at the different types of CVT designs which are available to us. These are metal pushbed CVT, toroidal drive CVT, variable diameter pulley belt CVT, hydrostatic CVT, magnetic CVT. Now let us deep dive into the pushbed CVT. This type of CVT uses a belt which transmits power between two conical pulleys, one fixed and one movable. A sensor reads the engine output and thus electronically increases or decreases the distance between the pulleys, which in turn changes the tension of the drive belt. Next up we have the Toroidal Drive CVT. This type of CVT uses rollers to transmit torque between the input disc and the output disc. A viscous fluid transmits torque between rollers and discs. The angle of rollers changes relative to the shaft position, resulting in a change of gear ratio. The change in angle by a roller must be mirrored by the opposing roller. To conclude this seminar, let us take a look at the various disadvantages and advantages which CVT provides over the conventional transmission methods. First up, we have the advantages that it decreases the engine fatigue. It provides infinite gear ratios, maintaining engine in optimum power range. It is more mechanically efficient than automatic transmission. It provides a greater fuel efficiency than manual and automatic transmission. It provides a smooth, responsive and quiet to drive experience. Several disadvantages of CVT are limited torque capacity compared to manual transmission, additional gear train needed for the reverse gear combination, larger and more costly than manual transmission, the unwillingness to discard billions of dollars in development in NT and ATs. Now, to conclude the seminar, let us take a look at the future aspect of the CVTs. The IC engine is nearing both perfection and obsolescence. Advancements in fuel economy and emissions have stalled. CVTs could potentially allow IC engines to meet first wave of new fuel regulations. Costs will be reduced further and performance will surely increase. Ultimately, it will give CVTs solid foundation in the world's automotive infrastructure. Thank you.